the Dusknet project. So generally, we'll start with just Meshnets and Darknets in general. So when you think about a Meshnet, a really big project out there right now is actually just called the Meshnet project, and it uses a piece of software called CJDNS. And it is what is purveyed, or what is looked at as the main Meshnet program. Though there's many meshing technologies out there, that's one that a lot of people follow. It's a really awesome program and project. If you haven't looked into it, look into it. I'm involved with it. Though I have my own meshing project, but it's two different things, as you'll see. And then Darknets, typically we think of Darknets as like a hidden network within a network, right? The hidden services that Dan talked about within the Tor network is considered a darknet, right? It's hidden services, things like that you can only get to once you have the proper software installed and it knows how to route properly within the protocol design. Now, a common one that's used is I2P. I2P is pretty awesome. It's like Freenode, but better, as in people actually use it, and like you can actually route the things, which if you guys have ever dealt with Freenode, that's actually been a problem with some things like that. So now moving away from those are typical systems that are used on people will use locally on their home computer or the home router and things like that. But they fail in a way that since of the hardware that they're using and also the implementation of certain things. And we'll get into that. So seeing that, I developed the Dusknet project. And the Dusknet project is a rapid deployable, self-routable, and intelligent mesh darknet in a box. What it does is you deploy units and it will say, I'm here, and then it will start automatically routing to other units in its space. And it's, we'll talk more about the algorithm that's used and what we're developing with it. But it's not like any open source meshing protocol right now. It's more closely aligned to meshing protocols that are used by the military. That were developed by companies like Mesh Dynamics or the Wave Relay system, persistent systems. So the need for Dusknet, unlike other Meshnet projects, Dusknet started actually when I was building comm gear for the military, and I was thinking like, okay, well, civilians in Egypt and Syria and China or whatever have their government shut down communications all the time. Arab Springs was a perfect example of this, where Egypt, you just saw it go black. And I was like, okay. Now, I was thinking, I build communications gear for the military. Why can't I build an open source alternative that has the same quality controls as I put into my military designs for civilians that can be used, or for journalists? Because that was a lot of things. You had a lot of journalists that are like trying to tweet out as much as I can right now. Update this, update that, and they would only be able to tweet a certain amount of times. And it's like, okay, well, sometimes they wouldn't be able to tweet, and it's like, that's because that whatever they were using to connect out was shut down or was taken out by a bomb or something like that. So that's where it first started. I was just lying in bed and thinking like, okay, well, open source, civilian use only, journalist use, but military quality. So then we had other situations happen here locally. Hurricane Sandy, people couldn't be able to communicate. And the Meshnet project started with communications for all. And that's how we wanted it to be developed. We want communications for all. There are some things that you do have to think about when you say that, communications for all. Now you are protecting other people that you might not agree with ideologically with their views on some things and how they communicate, right? They might communicate, I'll use a funny example, but it gets more serious than this. They might communicate, Vim sucks and Emacs is the best, right? You might disagree with that because it's blatantly wrong, but you have to also protect that. So while you are ensuring other people's communications and ensuring your own communication, you will have to ensure people's communications that you don't agree with. And that's some of the things that you have to look at, really. The Tor project is a perfect example of that. There are communications that go through the Tor network that a lot of us would not agree with, but we do have to protect it because it's universal protection. It's not just selective speech protection. So Hurricane Sandy, we had people that lost connectivity. Families couldn't communicate. Okay, well, we can have an open source alternative to the internet in a box. If I was you, I wouldn't want to accept a government-sponsored internet in the box unit and just be like, plug in your cell phone and you'd be good to go. Then we had the Boston bombing. All communications, not all, sorry. A lot of cellular communications were cut off during that time because they were worried that another bombing was going to take place. All right. Well, a lot of families were in distress. And the fastest way to make a community in distress is actually cut off all the communications. And you'll watch people panic. So now you had a bombing. You can't communicate through cell phone. You don't know why, because you're not a cellular engineer, or you're not a network engineer, and you're not thinking the government's cutting it off because they don't want other bombings. You're thinking, my phone doesn't work, the terrorists are winning right now. So why not have a system that they can be deployed and where they just plug in a SIM card and everything works for them and they have their contacts for their family already? So that's what the Dusknet project does. So the Dusknet project, it started from a very archaic box. It was a large box about this big. It was a cellular network, Ray. Well, that was great, but it's not really reproducible. And it's not military quality, and it's not deployable quality. So the Dusknet project involved into this. This case, IP67. All connectors are IP67. The hardware inside this case has been tested downrange. It has been put in a military unit. This case actually has also, as part of the system, has been deployed downrange and used in a military instance. So we know it's reliable. People's lives count on it. The military is not going to use some piece of equipment that they can't rely on. And it's a lot smaller. 3 pounds, 8 inches, 6 inches by 2 inches, instead of a 22-inch by 12 or 18-inch box. And it's a lot less power. So small, rapid deployable, and it's efficient. It's rugged, tested, and effective. It comes back. And now it's not bulletproof, so it can be shot and it won't come back, but it can be thrown around and it will come back. And our algorithm that we're using is a custom advanced algorithm that we are making right now. Actually, it's not fully made. I'm actually working on finalizing all the math for it before we start actually putting math to code. And it allows us to have a system that is much more efficient and a lot better than Batman, OSR, and things like that, that allows us through higher bandwidth, but it's open source and can be deployed on not just our hardware, but other people's hardware. And that was the main point. We always want to keep it open source. So this project is different. I talked about a few reasons. It's rugged, field tested. People's lives can depend on this. And that's what the type of gear that you want. I don't want to count on some home router that has some open source software that I agree with on it to be used to communicate with my family or to be used to contact or distribute journalistic information. That's not something that my job is going to be part of, and that's not something that I want to really have anyone else's lives count on as well. That's the problem with a lot of these systems. It's not just the hardware. It's also the systems aren't designed. The software on it's not designed to be used for a 5 nines type of setup. So it's supposed to be deployed in countries that are without communication. So we have to have ruggedized gear. These countries aren't always going to be first world countries where you have outlets everywhere, stable power, things like that. Your hardware has to be efficient and it has to be reliable. You might have your power die, your batteries might fail, something like that, but you don't want your board to die. The U.S. military actually does use this hardware. They went to a cost solution. There's a board in here, and the military uses one level down. It's designed by GateWorks. So we have the higher quality board in here, I guess. But they do use this exact hardware. There's 3 different companies that use this hardware. and have it deployed downrange. And it's easy to deploy and easy to use. There is no configuration for the users, which is another thing. A lot of these mesh projects are really complex, but that doesn't matter when you're in a war zone, because I do not want to pull up a shell when my ass is being bombed, basically. I want to be able to drop and go, and that's what you're able to do with this, is drop and go. And that's what we want to focus on when we start looking at, as a Meshnet community and a Darknet community, that's what we should be moving towards. And that's where, you know, we had a few people that were like, yeah, I like this. And then we're like, okay, well, now let's make a non-for-profit and let's actually move this forward. So that's what we did. So we have a few different units that I have here. We have the Wi-Fi unit. This is the ruggedized unit that is used for many cases. It's the most common unit. It's solar powered. It's very efficient. It has a backhauling technology. It doesn't use the 1 or 2 radio normal backhauling like you would think. It does use 2 radio backhauling, but it also uses independent channels where most systems will use the same channel when it's actually doing its backhaul. It is rugged. It's portable. It can be fit in any backpack. The backpack that I showed you that I was in beforehand, that fit all the antennas and the unit itself, as well as the power source and the solar panel. And the backpack's about a little bit bigger than that dollar bill that was laying on the ground. So small physical footprint. It's all those items when you think about building some type of military unit that you want to put. This item's 3 pounds. When you build gears for special forces, you don't want them to carry things. They measure things in grams. It's no longer pounds, because they want to be efficient. They want to be able to have equipment that's reliable, and they don't want to have to be debugging something or have to work on something that weighs 20 pounds and add that to their pack that's already decked out with everything that they need. So yeah, 3 pounds, there you go. So Cellular, this is actually how we first started getting into it. With the Meshnet communities, I realized, hey, there's nothing cellular in here. I can develop that. So I developed that big box. It was a GPRS-based cellular base station that people could connect to. Big box is not really a big friend. So I made that huge box into this tiny box. Uses software-defined radios, so you don't have to use the standard radio frequencies if you don't want to. If you want to deploy something else, another radio type, you can use this same box, and it does that. Again, IP67, small footprint. It's single power over Ethernet, and it allows you to connect. People's cell phones, that's the one thing I realized is people always have their cell phones, so why not be able to give them a SIM card that they can just authenticate to the network? Now there's different provisioning levels, you know. Are you on the first network? Okay. Are you on the trusted darknet? Okay. Now are you on trusted darknet, and who are your peers? So these are different provisioning levels that we can have. But everyone pretty much has a cell phone, and it's actually one of the most common ways that people communicate around the world is the cellular networks. Now, they have that device. They don't need any special hardware. Why not just give them a small, thin plastic card that they can plug in their phone and start communicating with their families now? All their families can be provisioned on the same network. The phone calls that you make are just the same. It's no new software that you have to learn how to make a phone call, right? Everything works as the user is used to it, which when you're in a distressed state, you want to go off muscle memory instead of like, oh my God, I have to learn this new piece of software. Let me try to send a message. Okay, now I have to say, you know, the special keyword, and they have to enter in this number. You don't want that to happen. So then communication. Now, when these servers or when these countries lose connectivity to the backend network, they usually cut it off by BGP. So why not have resources that you can have within your system already there? This goes back to like the hidden resources on the Tor network, hidden resources on CJDNS or I2P. It's the same thing, but all you have now is usable resources. So like a copy of Wikipedia, a chat program that allows people to communicate to Twitter when this thing gets out to the internet. So you can deploy one of these within a Dusknet system or multiple of these within it, and then it has a twin server on the back end. All of them only need one twin server. And you do not need a IP connection. You do not need some working routing protocol going on. It doesn't need any of that. As long as you have some point-to-point physical connection, that physical can be medium as well, to somewhere where it can communicate to a back-end network, then it will send data. It doesn't rely on IP. It doesn't rely on typical routing protocols that we're used to. This is unique in the fact that you need point A, cable, air, whatever you want, point B, and it will communicate. And that's what we want. We want journalists who are here to be able to tweet out or to be able to send information that they want. We want families that are in these areas to be able to call their other families. And that's what the Meshnet community really wants to do. And that's what Rapid Dark Networks really wants to do. We just want to make it so that people can do it reliably. So this is the current Meshnet solution right now. They have these high-powered, usually 1 kilometer units that's 1 kilometer point-to-point communicate to each other. This map right here is actually the capital of Syria. This is 180 of those high-powered units within the current Meshnet technology. And these are, can be whatever. They're made by 2 different companies, pretty much the same hardware, but they're not really ready for deployment type situations. But these are 180 of them, and that's point-to-point communications to allow you to get this range. That's not what we're really looking for. 180 units, you need a lot. It can be found a lot easier. They are a little bit smaller, but if you have 180 of them, you now have to have 180 power sources, things like that. So this is a bad idea. And the Meshnet community generally agrees with this. So say, yes, it's not the best solution. That's why we're trying to come up with better solutions. Now, when you have 180 of these units, your current meshing technology actually won't work. You can have a maximum of 40 units in a single route mesh. And what I mean is this unit connects to like this unit, this unit, this unit, this unit in a line. And your maximum throughput, though it will work if you can have technically, as many units as you want, or theoretically as many units as you want, your maximum throughput after 40 units is only about a megabit or 2 megabits per second, which is extremely slow, especially when you're trying to process information from a whole bunch of people using that one end unit, let's say, trying to communicate all the way back. 2 megabits per second is not efficient at all. It's not efficient enough for reliable communications to get out. And that's what we want to address. So, yeah. Well, that's perfect, actually. So this is the same map, Syria, again, capital of Syria. And this is 7 Dusknet units with a 10 kilometer range. This is point-to-point backhaul. If you guys see back there, that's what it looks like for point-to-point within the Dusknet units. You guys can check it out afterwards, or you might have already seen it. That's what it looks like. Of course, you can paint the antennas so they're not white, and we'll talk about hiding antennas and things like that. Then the routing mesh protocol, this is just simple, you can have units. As long as you supply units, you can resupply units. Links will keep on building themselves. And unlike other layer 2 meshing that you typically run into problems, we are using layer 3. I can talk more in that in depth after this presentation. So connecting out to the internet. So multiple ways out. This is what we really want to address, and we enable these type of services within these units. So you have standard POTS lines. Okay, everyone uses that. That's a good way to use if they cut out BGP routing. That's what they were using in Egypt. People were sending modem banks over there so that they can communicate. We can also use SATCOM. I recommend BGAN over VSAT, just because I find it more reliable from my experiences with those two. Long-range Wi-Fi, as we have in the back. We have a theoretical maximum of 50 kilometers with no amps. That's just with standard hardware. Realistic maximum of 32 kilometers. We've done testing with 10 kilometers, and that's what we found works the most reliable as well as fastest timing. Also, you have point-to-point cellular, microwave, and packet radio. This is a big conversation in the Meshnet community right now is packet radio. Packet radio is awesome. 96 kilobits, or 96 baud, or 9600 baud actually. It's slow, but it's good. And it's long range. And the hardware is relatively cheap, if you think about it, and easy to get. Yeah, powering it, solar, wind, battery, regular Edison. We've tried all these ways. They work. Solar and power and wind are the most common ways that we think would work downrange. Solar has been tested downrange before. Smuggling, that's not for this talk. But hiding units. Okay, well, styrofoam is invisible to RF, so why not make it look like rubble? And a place got bombed. If they're a war zone, there's going to be areas that are pile of rubble. You can hide these Dusknet units and a styrofoam block that looks like rubble. A lot of just think of it like a movie set. Maybe put the routing board in a laptop now. A little less protection, but it looks like a common piece of hardware, and you could still have the laptop work if you change some of the hardware components of the laptop. So yeah, there you go. Or if you got something for Christmas that's a piece of crap, then you can also use that. And yeah, I mean, no one's going to be using that for reality. I mean, what are you going to do? Just invite the FBI and NSA into your house? So things that we're working on. We are working on the meshing protocol right now. It's not completed. Spectrum mapping in different areas. I'm talking to a few people that live in different countries. They actually have spectrum analyzers. We're doing mapping analysis so we know what radios to actually put in here. We have a total combination of 8 different frequencies that we can put in these systems. And depending on the area, we want to be able to be like, hey, this place lost internet connectivity. We know these radios will work best based off other spectrum readings that we have. So now we can deploy those 4 radios in this unit and have the least amount of interference. Open source intelligence. Dan talked about Palantir. We're working on the open source kind of version of Palantir, just a lot less scary. Palantir is a really scary company. You don't want to fuck with them at all. But we want to take what they do and be able to monitor things like Twitter and BGP. Actually, Zach is leading that effort. It's one thing he really liked about it. Smaller, faster, cooler, more efficient. Always want to make it smaller. If we can fit it in our hand and it can communicate 100 miles, well, 1, you've just broken physics somehow, and 2, that'd be awesome because now we can be more efficient in how we power it. So yeah, any questions? No? Okay.
Are they going to open up any frequencies in the U.S.? I heard talk they might for this type of thing.
Yeah, so they've, oh yeah, the question is, are they going to open up any frequencies? So in 2008, they opened up a lot of TV white space spectrum to be used in a non-Wi-Fi. Wi-Fi is really messy and ugly protocol manner. That's actually one of the things that we have is we're working on, or we have, but we can't use it because it actually infringes on another company's patent. But it's a meshing network that uses TV white space. There's also pilots going out with the 3.8, or no, 4.8? 3 or 4 gigahertz spectrum somewhere in there that deals with WiMAX that are going to be self-managed. So like the users are going to start managing it instead of having the FCC manage the frequency allocation for that. Yeah?
One slide said that LTE service was you were working on it.
Yeah.
But you keep mentioning a first SIM card. What about folks without SIM cards?
Yeah, so like use CDMA or something like that. So that, what? Oh, so the question is, we talked about LTE, but then we also talked about people using SIM cards. Now, not every phone has SIM cards, and that is correct. And we realize that. So if your phone doesn't have a SIM card, another step that you do, another step that we have is we call it the bug out box. And it's just a simple box that has pre-provisioned SIM cards for you and your family, as well as 4 cell phones that will take that are pre-provisioned, that have actually an Android app that we use to have your device connect to our network in the most secure manner that we can think of right now. So If you don't have anything, if you do have an LTE phone, once we do have LTE working, with the hardware that we have, it's another company that's working on that. We're not directly working with it. We're just doing testing with them. If you have that, a lot of the LTE channels that we're using at AT&T. So if you have Verizon, you kind of be screwed. Yeah, so it's either get a different phone, a backup phone, or we might be able to eventually switch over to the same LTE standard that Verizon uses, which still relies on the SIM card because they were smart and went with the 3GPP implementation of LTE. So yeah, it was a quick overview of everything. There's a lot more detail and a lot more technical information that goes into this. This is why I don't sleep.